Hey guys, we're the Rational Duo. I'm Kim.
I'm Katie. Today we're going to be going over Module 3, Chapter 10, Length, Area, and Volume. So jump right in. Kim, what is a pictograph and how is it useful to students?
So, a pictograph is a way of showing data using images. It's also a way to explain things using pictures rather than everything in words, giving our students like a more visualization of an object or of an explanation without just telling them. So, we're going to look at this image I have provided us. It's just an image of a paint can, and what I would want to tell our students is, think of this paint can and think of all the colors you would like to have in it. And a pictograph is a way of, representing how much of the color is in the can. So we can just do a little quick example here. Sorry, let me grab my annotation tool out and grab a color that's not pink. So what would we do here is say someone, what if we're doing class colors? One student wanted purple. I'm sorry, this is not pretty. It would take too long. One student wanted blue. Do you see where I'm going with this?
Absolutely.
A pictograph is just a way we can show and represent how much in our case, how much of each color is in the paint can.
Okay. So, that's great.
And that's really, it's actually fairly simple, and it's just, I think it's a great and useful way to help our students, engage and be more visual.
Absolutely. I think that's a great tool for students because even for me, I'm a very visual learner. And so even just drawing a picture, even encouraging students to make their own pictograph would be great. If the problem says, we're going to fill a paint can today, well, draw your own paint can, and visually put it in there. I think that's a great tool. Thanks, Kim.
So now that, we started talking about pictographs, will you give us, an explanation of what a doubling system of capacity is?
Sure. So you can see here, of course, our key. So on our key, it shows that we have, of course, MF is going to equal 1 mouthful. So let me get my annotate as well. So we can draw here. So taking a look, let's say we have 2 MFs, so 2 mouthfuls. So 2 mouthfuls is going to equal 1 jigger. Okay, so if we double something, another way to say doubling is to multiply or times it by 2.
Of course.
So let's times that by 2. And so if we times it by 2, then we would have 4 mouthfuls. And so 4 mouthfuls is going to equal a jack. And so if we, times that by 2, then that is going to equal what we're going to call a Jill. Sorry, I'm losing my pen here.
No, you're fine. Take your time. I was messing with the pen
too. Technology, isn't it great? So, and we're just going to keep doubling those. So if we, of course, times that Jill by 2, then we would have 2 Jills, but another name for that would be, and this is where it's going to start to sound familiar to you, a cup.
Yes.
Okay, so we're familiar with a cup. So if I have 2 cups, or if I have 1 cup and I times it by 2, which is the same as saying that we have 2 cups, then that will equal what is called, and again, you're familiar with a pint. So that kind of gets into, kind of our US, fluid measurements, and it kind of gets into that. So, you just keep going until it sounds familiar to you. And for me, with this, I was a little confused with it, but then once I saw, started to see those words that I was familiar with, the cup and the pint, then I could say, oh, okay, and I worked my way backwards. So again, having that visual representation was great for me.
Oh yeah, that's what I was going to point out. just seeing it, honestly, just seeing it just makes so much more sense,
Absolutely.
You can see, a mouthful equals 1, right?
Yes.
So 2 mouthfuls equals jiggers, and so on and so forth. I just think it's a great visualization. So we're basically saying, 4 mouthfuls is a jack, and 16 mouthfuls mouthfuls is a cup, 8
Yes,
mouthfuls is a Jill. No, I think it's a great
absolutely.
representation, and I love that you use that chart to just, explain what a mouthful is because, just saying MF like has no representation at all.
Of course, and we could have put stars instead,
Yeah.
or we could have just said one box equals a mouthful,
Mhm.
so I'm just encouraging students to use, whatever makes sense to them.
So you could also use that with like any other, image. I mean,
Hmm.
I know that we use, actually here just like, little boxes to do it. But like
Absolutely.
do you think like you could use that like with any objects maybe?
Yes, you
Yeah.
absolutely could.
Like I mean just the
Absolutely.
little visualizations in the classroom and stuff like that.
Yeah,
Just out of
of
curiosity.
course.
Sorry.
All right. So moving on. So we've talked, of course, about some measurements, doubling systems, but what is perimeter, Kim?
So, when we're talking about perimeter, with a shape or an object or, anything like that, perimeter is always going to be the same. So it's going to be the boundary that surrounds a shape. It's also going to be the length of the outline of the shape and the sum of all the sides of the shape added
Hmm.
together, the sum. And we could also write that out. Sum equals all the sides added together. But so
Hmm.
I presented this image, just to point out a couple of things, and I'll talk about it in here just a second.
Okay.
So we have three sides of this, triangular shape, and one side is 48 meters plus 69 meters plus 82.3 meters will give us 199.3 meters.
Uh-huh.
And I wanted to point out because we have three sides, and I feel like a lot of students would see um, that that line in the middle. They might consider that as a shape, and it's not because we're talking about perimeter. So the perimeter is all the measurements outside the shape added up.
Uh-huh.
So that 41 would be considered the area. So
Okay.
maybe now that we know a little bit more perimeter, we could talk about area.
Okay.
So, explaining that, hopefully you could explain what area is since we already covered.
Yes. So you were talking about perimeter, and an example that I love to use is say we're going to build a fence. And
Okay.
so for that fence, I always explain that, if we're building a fence, the perimeter, and let's say we're building a fence for our dog. So the perimeter is going to be, of course, how big our fence is. The perimeter covers the area. So the outside of this rectangle here on our yard is, of course, going to be where the fence goes. That's going to be our perimeter. But all
Mhm.
of this pink here on the inside, all in here, right? That's
Yeah.
all going to be our area, that lighter pink.
Mhm.
So let me erase what I just doodled.
Oh, you're fine.
Figure out how to do that.
You just
Well, I
click here.
can't, but that's okay. So, well, I'm just messing it all up, but that's all right.
Oh, fine.
So with this, I can't get it to work. I'm messing it all up. I
You're
do
fine.
apologize.
Can you clear it, like through annotations, maybe?
No, it's not
No.
letting
Oh,
me.
that's fine. I would just write on the side.
Oh,
Oh,
that's
there.
what it is. I've got it. I've got it now. Okay. So, with this, going back to it, sorry about my technical difficulties today.
You're
Um,
fine.
so, um, we're going to be looking, of course, we know the perimeter is going to be what our fence covers. The area is going to be the inside of the fence. So with that, I just wanted to point out a couple more words that we will kind of get familiar with throughout the presentation. So anytime that you have a rectangle like this, you can write a D right here, and that's going to be for the diameter. And then I want you to put an L down here at the bottom. That's going to be the length, and then a
Mhm.
W here, and that's going to be the width. Now, the reason that that's important is because if we were going to work this problem, we would already have our rectangle labeled, and all you would have to do is grab the numbers that were in these places to
Mhm.
plug in to the formula. And the formula to find area is A, which means
Yeah.
area, A-E. That is not how you spell area. Anyhow, A
You're fine.
equals width times length,
The
or
length.
length times width. And so
Mhm.
you would just plug in, of course, the numbers for that.
Yeah,
So
and I think
forgive my spelling
well,
and technical difficulties today.
oh, you're fine, you're fine. So going with that, we know that perimeter is strictly the area outside. Oh, I shouldn't say area actually, is all the links added together on the outside, and area is strictly, length times width on the inside to figure out how much space is inside the fence, perhaps,
Absolutely.
rather than how long the fence is.
Yes.
I felt like that was a great visualization. I'm glad you explained it.
Yes. And aside from technical issues, I would have
Very
explained it a little bit better, but that's okay. We roll with the punches here.
fine.
So speaking of area, how would you find surface area, Kim? Could you explain that?
Of course. So, we talked about perimeter and just basic area. Well, surface area actually has a different formula, which this formula is 2b plus pH. And explaining those, b would equal the base, um, p would equal the perimeter, and h would equal the height.
Yes.
So what I would like to do, which I know I didn't tell you, what I would like to do is for you to make up a couple numbers, and maybe we could work it out together to, maybe,
Yeah, that sounds great.
letting our students just, pick it out for us, I feel like would help, make it more interesting for them.
Yes.
So we see that, we're going to say 2 times our base. What would you like our base to be?
4.
4. Awesome. Easy. So plus, what would you like our perimeter, all the outside links added together, be?
6.
6. Okay. And what would you like our height to be? How tall
10.
would you want to drop it? 10? Very tall.
Yes.
Okay. And then so we would know surface area would equal, and I'm going to plug and chug that real quick. So we would do 2 times 4 plus 6, times 10. There's no way I can do that in my head. So whether we were doing, whatever units we've done, we can just say, go ahead and just say 68 feet. So if we were looking for the surface area, I know this may not make a lot of sense. Let's just say the surface area of a pool. We're just going to say it's 68 feet. So, I mean,
Absolutely.
just, pretending, or the surface area of a building.
Sure.
So it's
Okay.
easy, and it's fun, I feel like.
Yeah. So I think that really goes with what I was saying on my slide before, that being able to label, of course, if you're given a shape, or, like we said, just drawing your own shape and being able to label, then you can say, okay, well, that's the height. And then that, for me, it would definitely help me plug the numbers into the formula and help me understand it a little bit better.
Of course. I mean, and that's great. And I feel like a lot of students could, fit in that circumstance. And I also think that, when we're, even throughout my classes, growing up, sometimes we just do math and I wouldn't even know what any of it would stand for. So I'd always have to make side notes. What does B stand for? What does P stand for? What does height stand for? Because if you don't know it, you're not going to obviously figure anything out.
Of course.
So
Of course.
I always like to label, and I feel like, most of our students should always label what everything equals, even
Absolutely.
if they are.
Of course. That's great.
Thank you. So finding the surface area, we've talked about perimeter area, surface area, and all that.
Mm-hmm.
So, since we're talking about shapes and objects in space, how would you determine the radius of a circle?
Okay, that's a great question. So for the radius, I just want to point out a couple things here. I went ahead and we drew a circle, and I went ahead and labeled. So of course, this line right here in the middle would be our diameter. And that's, of course, it starts here and it ends here. That's going to be our diameter. This right here, this circle is going to be the center of the circle. But what we are looking for, of course, is the radius, which is going to be the line that starts at the center and it goes all the way up to the edge here. So what is the radius? The point from the center of the circle to the outside edge of the circle here. So for that, there's a formula. We love the formulas here. So R stands for radius, and I'm not even going to try to spell it this time.
It's okay.
R equals, the formula is C over, which it makes a fraction, 2
Mm-hmm.
pi. So
Awesome.
for that, we're going to plug in a number. So let's just say that our circumference is 20. So let's say C equals 20. So all we
And
would do is do 20 over 2 pi. And so that would equal about, so we make our lines, instead of saying the equal sign, straight lines, we do these kind of squiggly lines here. And that means about 3.18 if we were to actually do that math.
that is awesome. I
Yeah.
love that, and like we just did before, I love that you tell us what C is and what it stands for. It stands for circumference, and and I also
Mm-hmm.
love the visualization you have here, like we talked about earlier. Students always like to see things happen, not just be told and written. It kind of goes along with like the pictograph, I guess.
Mm-hmm.
So you're saying that the diameter is the total length, of a circle, and the
Yes.
radius is the
Mm-hmm.
center,
Yes.
to the
Yeah. We
That's
also
awesome.
hear radius, it could be called, referred to as the ray as
Oh,
well. And
mhm.
something that I always, whenever I was younger, that I would always think of, because you don't just, the ray could be any, or the radius or ray could be
Yeah.
anywhere. So forgive my non-straight lines, but
Oh,
it
you're
literally could be all through here. So I always thought that if you took these lines and you flipped them on the outside, it makes the rays on the ray of
fine.
sunshine.
Oh, that is a great way to
So if I
remember.
flipped that back in, if I flip that line back in, I know they're not straight. I'm not perfect here in my
Yeah, no,
drawings. But if I
I
flipped it back in, then it would be like the rays of sunshine. So we flip
mhm,
them in so we can pretend that the sun's sleeping and its rays go in and
uh,
it's hugging itself, right? We flip them
yeah,
out. So it's kind of a way that I always thought of it.
that is great, and I love that. I feel like, like we said, in our previous team teaches, teachers don't realize that these little things that they do to explain something impact and forever make you remember them, and that is what makes them like a good teacher. They make it fun
Yeah.
to learn and do little tricks like that, because I bet you learned that when you were little. So
Yes.
I don't know. I just
Yes.
think it's awesome. That was great.
Absolutely. All right, well, let's jump into the next one. So we've talked about, of course, radius and, area, surface area, but what about volume? So Kim, can you tell us what even is volume?
Yeah, of course. So, volume is a measure of how much space an object takes up. Like this laptop I'm recording with, it takes up space. These
Mm-hmm.
my lamp takes space, you take space. I mean, it's
Mm-hmm.
just, every object takes space. I mean, so, the volume is a solid object that's measured in cubic units.
Okay.
So, I had a little visualization here, of a cube. And you see we have three sides of threes. And so back to what we were saying, all dimensions must be in the same units. And that's whether it's centimeters cubed, and centimeters square, all dimensions are in the same units. So we
Okay.
see that we have three sides of three. So we're just going to easily multiply those. So we have 3 times 3 times 3, which would also be 3 cubed, and that's 27, 27 whatevers, but we're just going to say it like that because, going back, we see it's all measured in cubic units. So whether it's cubic feet, cubic meters, all that,
Yeah.
you know, so it could be cubic inches as well, but we're going to go ahead and say 27 cubic meters is written as 27 meters cubed, or 27 cubic meters is written as 27 feet cubed. You see where
Okay.
I'm going with that? So
Absolutely.
and that's just for this cubed object. So I also have another visual that I'm going to show you,
Okay.
and
I do
it's
have a
going to.
quick question though.
Oh yeah, of course.
So, with this, I know that there's kind of a formula for the cubes, but is there a formula for other shapes?
Yeah. See, that's what. See, we learned basically. Um, we see that's just in general for volume. So
Okay.
we have other formulas here as well. So we see we
Okay.
did cube, which v would equal s to the third, which is s cubed obviously. We just did it.
Okay. Yeah. Yeah. Yeah.
So let's look at the rectangular prism. So we see that we have V equals length times width times height, or we could just do V volume equals base times height. I would just do base times height because it's much easier.
Mm-hmm.
So we just multiply those together, and then the sphere would be volume equals 4/3 pi r cubed, which you went over radius and all that kind of stuff.
Of
So
course.
the right circular cylinder is volume equals pi square times height. Right circular cone is volume equals 1/3 pi r squared times height. And I've used that a lot personally in my life, so I kind of just remember that right circular cone for some awkward reason. And then
Mm-hmm.
we also have right square pyramid, which is volume equals 1/3 s squared times height.
Okay.
And all of those have specific cubic units, and all that kind of stuff. But it's good to just know these formulas. And I'm sure they'll always be given to our students because we don't expect them to remember all of them, but we do
No.
expect them to remember, the volume of solid objects will always be measured in cubic units, so,
Mm-hmm.
but
Absolutely.
sorry, that kind of
Well,
took a
no,
minute.
no, that's great. I think that having these formulas and having them labeled is great for students. This that picture does remind me of the pictures that you see in the teachers' classrooms that have
Yeah,
the formulas
that's
on
what
it.
I was thinking, like,
It's a
kind of
great
just
reference.
thank you.
Absolutely. Well, thanks, Kim.
You're welcome.
So jumping in to pi.
What is pi,
Um,
Katie?
Well, pie, first of all, we all know what pie is. My personal favorite is a pumpkin or apple pie. What kind of pie do you like, Kim?
Oh my gosh, I can never decide. I think I like blueberry pie. I just love
Blueberry?
blueberry.
Blueberry's not for me, but that's not the kind of pie we're talking about today. So I tricked you. So that symbol that you see there, that weird, this symbol right here.
It almost looks like
It almost looks like what?
a table.
A table, yeah, a weird
Right.
crooked table. So I more commonly see it kind of like this, but maybe that's just how I draw it.
No,
Anyhow, yeah, so however you see it, however you write it, we all know what it means. Or we recognize a symbol in math when we see it, and that's
Yeah.
because it's actually a Greek letter and or Greek letter or symbol for the word pi.
Awesome. That's actually really cool. I didn't know that.
Yeah, so pie that we eat, let's write this over here. Pie that we eat is P-I-E. Math pie is P-I. No E. No E for eat, unfortunately, but maybe we can have some pie later. So the Greek letter, of course, for pi is that symbol there. And what it means is it stands for a number that never ends. And I don't have that full number memorized. I don't think that anybody does, but it could literally go on for infinity. And we know the infinity symbol is like a sidewards 8 here on its side, an 8. So it can go on for infinity and beyond. But for short, we call pi, it's just kind of a well-known that pi stands for 3.14. And we can put this little symbol right over here because we know that it goes on forever and ever and ever and ever and ever and ever and ever, and it never ends. So
I love that.
Yeah. So we know that pi is the ratio of a circle's circumference, and that's just kind of like an understood thing. I know in school we always would celebrate Pi Day, which is March 14th, which is 3.14 Pi Day.
Well, awesome.
So that's always fun.
That's awesome. And oh my gosh, I feel like I always have to repeat this to you. That would stick for me forever now. I am not going to forget that.
No.
Pi Day.
Well, I think coming up with silly ways is the best way to remember things. What I do have trouble, though, remembering is the difference between, and I know earlier you said that we could have any form of measurement, so centimeter, feet, inch, mile, but for this, let's just talk about what's the difference between centimeter cubed, and centimeter squared. I don't understand the difference. Could you help me with that?
Yeah, of course. So, when we're talking about, the difference, so let's just think about this. So when we're talking about, just, and it doesn't have to be centimeters, it could be inches, it could be feet, like we were talking about earlier.
Mm-hmm.
So the difference between, just centimeters, feet, square, whatever, and the difference between centimeters cubed, inches cubed, or inches squared, it's all fairly simple because it's all just talking about referencing dimensions. So just straight centimeters or inches or feet is simply, it just has one dimension. Because a lot, when we're talking about math, when we're going to the first power, we never really put the first power because it's understood as one
Mm-hmm.
dimension. So, they're just one-dimensional shapes that are measured in only one direction,
Mm-hmm.
So, for example, like lines, it's like just straight lines, segments, or, rays, like you were explaining earlier. So,
Mm-hmm.
like centimeter squares or inches square would be like two-dimensional objects where, flat shapes like circles and squares would come in shape. And you can look at my visual right there where I have, the dimensions labeled 1, 2, 3, and 4, which I only went to 4, which there's more. I just
Of
went to 4,
course.
just break it down a little. Centimeters cubed would be three-dimensional objects that are more like, cubes and spheres. So I mean, and then we also have hypercube, which I didn't explain that, but that would obviously be four-dimensional objects, like a hypercube, which is very
Okay.
complicated looking at it. Kind
Yes, it
of
is.
scary. Yeah, I mean, it's pretty simple. It's just, it is simple, but I notice a lot, like when you're referencing stuff like that, I really didn't even know what it meant, but it's
Uh-huh.
all
Yeah,
talking
it's just always
about,
something you understood.
yeah.
Yeah. Okay. Well, explaining all of that.
Um, yeah, so sorry, explaining all of that, could you tell us what a base is?
Yes, of course. So, I have a question for you referring to this. Whenever you look at this shape, what is it?
I see a cube, but it could also be seen as a square, or
Yes.
vice
So,
versa.
yes. So, and I'm going to click back to your slide real quick to show, of course, keep this image in mind.
Mhm.
Looking at yours, I specifically look at this right here, this shape,
Mhm.
and this shape. So see how, of course, this has a 2 and this has a 3. Keep that in
Mhm.
mind, okay? So whenever we look at this, of course, right now, because we're, of course, on a computer, this is what's
Yeah.
going to be called a two-dimensional shape. But
Mhm.
if we were in person and we were in a classroom and we're holding this shape in our hands, it would be
Mhm.
what's called a three-dimensional shape,
Of
meaning
course.
we can flip it over and we can see all the different sides of it. And if we looked at those sides, you kind of already answered the question, you would see that it's a square. It's a square right here. You see 1, 2, 3, 4, 4 sides right here. So this is 1, that's 2, and that's 3. And that's just 3 squares that we can see. But there's going to
Mhm.
be another square on this side, so 4, another square on this side, it's 5, and then another square on that side, so it's 6. 6, I believe, yeah, 6 squares total. So if we have 6 squares that make up this shape, then you tell me, Kim, what's the base shape?
Um, so would it be like the platform on the, like if
Yeah,
you're
so if
would
you
it be
have
like
squares on every single side,
Mhm.
then the base shape would be a square.
Yeah.
So the
Yeah.
base, it's just the solid base that a shape stands on.
Mhm.
So
Yeah, I
if
get
you were to
that well.
have a cone, no, you're fine, you're fine. You weren't
Mhm.
really expecting that question. So let's say that we have an ice cream cone. Let's think a little here. Let's say that we have an ice cream cone, and forgive my awful drawings. But so let's flip our ice cream cone upside down,
That was a
right?
great drawing.
Well, thank you. So of course, this is going to be the sides right here.
Mhm.
And this shape right here is going to be the base because that's what it's standing on, right? It's the flat surface. So this point up here, whoops, this point right here, it's a point. Can it stand on its own?
No.
On the point? No. Now, if I put, something to hold it up, if I had my hand in the cone, then it would stand up, right? But I can't lay it flat on the table and it won't stand up on its own. But if I flip my ice cream cone over, then, and I put, that open circle on the table right here, then that circle is going to be our base. So whatever the shape stands on is going to be considered its base.
So like I understood, like platform, like
the platform, absolutely.
The earth that we stand on is our base,
Yes.
Is that good? That's a good way for me.
Absolutely, absolutely. So we've talked, of course, about bases and everything, but what is slant height?
So we talked a lot about like length, area, volume, perimeter. I just picked this question out because it's something that's never really actually ever pointed out, So it's kind of just something that's fairly simple. I just have never noticed until reviewing in our homework, So we talk a lot about just basic height, which our basic height would be, obviously we could see here our height would be 10 meters, That's how tall it is going up, and then our width, how long this side is 2 meters. So, a question that's never, what would this even stand for? So what do you think about when you think of a slant? Not even just height.
Personally, I think of like the slant in my rooftop.
That's a good visualization. You think about the point of your house. You don't, when people, how tall is your house? You're not thinking about slant height. So the slant height would be the start from here to the very point, how long that slant is. So if you think about a hill, it doesn't have to be a house. It could be anything. You think about how long does that hill decrease before going straight again. That's like a slant height,
Okay.
That's the way I can visualize it. So yeah, our slant height would be equal to 6 meters, or whether inches or whatever. Oh, let me clear that.
Oh,
so
no,
I mean,
fine. I didn't know if you had more to click.
Oh, no. So it's just a fairly simple, question that's just never really understood, So nobody asked, well, what's the slant height of your house? Or,
okay.
Slant height.
Well, and that's a great, I liked the example that you gave, talking about a hill, so whenever I say, how tall is that hill? I'm not saying, I'm not asking how tall is it? I'm actually asking what's the slant height of that hill?
Yeah, because a hill isn't just tall, it's steadily increasing in a slant, height motion. So it's just kind of like how I visualize it,
Absolutely. So. Well, thanks for sharing that, Kim.
Oh yeah, so now that we're talking about slant height and everything, I just this is probably the biggest question of all to me. More questions and everything. What is the Pythagorean theorem? Sorry,
Pythagorean. Say that 10 times fast, huh?
Oh, no way.
Pythagorean theorem. So let me try my best to answer that. So the Pythagorean theorem is the square of the length of the hypotenuse of a right triangle that equals the sum of the squares of the lengths of the other two sides. Boy, that's a tongue twister, and I don't understand that. I don't understand that. So
maybe you can break it down for us.
Yeah, so let me try my best to break it down. So again, here's the formula. So forgetting what we just read, a squared plus b squared equals c squared. That's the Pythagorean theorem. So what that means, how we find that, so A is going to equal the side of a right triangle. Then B is going to equal the side of a right triangle, and then C would equal the hypotenuse. And so again, we would just take those numbers. I'm not actually going to work one out today. But we would just take, of course, the numbers and we would plug them into that formula like we've done on many equations here, and we would plug them in and type it into our calculator, and it would help us give us the answer, and we could work that problem out.
Yeah, no. So, I mean, and that's kind of how, like, as we talked about all these formulas, it's really just a plug and chug. I mean, you can
Mm-hmm.
do the math in your head, but I mean, it's a lot. But like you said, and like I said, as long as you label what everything stands for, it'll be easy to spot, what number
Absolutely.
on your answer.
Absolutely. Well, I
So
think that's all we have today. Anything else, Kim?
I think that's it. I think that was fun and a great teach.
Absolutely. Well, thanks, guys. We'll see you next time.
Bye.